Good afternoon. Welcome to physics class. From today, we will use two classes to study Gauss' law for magnetic field. First, we will introduce the basic concept of magnetic field and the magnetic lines which describe the magnetic field. Okay. Now we start from very simple phenomenon. The first is if we have magnets and we have iron, if we put them close to each other, what will happen? A magnet, and iron. So if they are close to each other, what will happen?
The iron will be attracted.
Yeah, right. The iron will be attracted and touch the magnet. So the second one is if we have two magnets, both with north poles and south pole. If we put two magnets like this and we fix the position of this magnet, what will happen if we put this close to each other?
It will repel.
Excuse me?
It will go away from it.
Yeah, it will go away from each other. Or if we fix this point, it will rotate. And the third example is the same magnet but we put the south pole close to a north pole. What will happen?
Attracted.
Yeah, attractive. Okay. Why this phenomenon happen? Because around this magnet there does exist a magnetic field which applies a force to this magnet and either head away from this or attract this. So how can we describe this magnetic field? Consider in other area, if we want to describe the flow of the air or the flow of the river, usually they use streamline to describe the particles of the water and the particles of the air. For example, if they have a river and they have a boat, they usually can use lines like this to describe the flow of the river. And if the river is very fast, the density of the line will be very high. So we use the same concept here to describe the magnetic field. Okay. I take this magnet as an example. If I have a magnet like this, how can we use the concept to describe the magnetic field? We can start from the north pole. So some lines goes from the north pole to infinity. And some lines will go back to the south pole. For the south pole, the case is the same. The more dense line is, it means that the force of the magnetic field will be strong. So if we put these two magnets together, what will happen? I will just take one for example to describe why this happens. Okay, if we put these two magnets together, their magnetic lines will be like this. They will get away from each other. So if if we put the North Pole toward the South Pole, a line will go like this. So they will be attracted from each other, and then for this case, they will get away from each other. Okay, so does anyone have any questions about this?
So are the lines just like imaginary, or are they like?
Right, they are imaginary. We just use this as a tool to describe the magnetic field. Yeah. Okay. So another example is that our Earth is a big magnet. So if we imagine it, it can have magnetic lines like this.
I have a question.
What?
Are those lines continuous or discontinuous lines?
This is not very important.
Mm-hmm.
Yeah, we just use this kind of lines to describe. Usually we use dash line.
No, I mean,
And
are they
dash-
continuous lines or they are discontinuous lines?
They are discontinuous lines.
That means we don't have lines inside the magnet, right?
No, I understand the pattern. No, we have. But usually we do not draw it. Yeah. So around the Earth, we will form a magnetic field which can protect us from the particles from the sun or other radiation. Okay, now we know the basic concept of the magnetic field and the lines, how to describe this field. We will go to the main part of the Gauss's law. So because of the time reason, I will give you the two forms of the Gauss law, which are the mathematical expression. The first one is a differential form. This one, you should write this on your notebooks because these two equations are very important. The second one is integral form. Okay, in next class I will explain in details about these two equations. The general idea of the Gauss law is that